Hey y'all, it is time for our Unit 2A pre-test video for honors. So I'm going to go over a couple of things for you guys just to kind of help you get ready for it. So first off, I want to review domain and range. So you can follow along or you can try and pause your video and draw what I've got drawn here. Alright, so a couple of things. Let's remember that domain is how wide is my graph. Because x goes from side to side, how wide does it get? So remember, one of the easier ways to do this is to just label your extreme endpoints. So this is the furthest point over here. This is at -2, 2. And if I go all the way out here until I don't have a graph, the last one I have down here is over 6 down -1. So find your two very far endpoints, and then let's just look at the x. Let's not look at the y value. So it goes all the way out here to -2 and all the way over here to 6. So I see that this is continuous. Once I know it's continuous, I'm going to have something less than x less than something. I just have to fill in those blanks. Well, my far left is -2 and my far right is 6. Now I need to decide, do I actually equal -2? I see an open circle right here. That means it's not included. Remember, open circle, open, means it's just greater than or less than. And then remember, when you have the closed circle, the closed, you have greater than or equal to, less than or equal to. I have an open circle, so I'm not going to put the equal sign underneath it. Over here, though, I do have a closed solid circle. So that means I do physically equal 6. All right, go back and watch that one more time if you need to. How wide is it? Now let's look at the range. Range is how tall is it? Well, you know what? Again, I'm looking at a continuous function. And if I'm looking at continuous, that means something less than y less than something. I just need to find my two endpoints. Okay, well, let's look. How tall does this get? What's the very highest point it reaches? That is over 0 up 4. And what's the very lowest point? That we'll call that over 5 down -2. So if I'm looking at range, I don't care about the x value. I'm only looking at that y value. It's going from -2 all the way up to 4. Got two extremes. Low goes on the left, so -2 less than y less than 4. Do I actually equal? Well, this time I don't have any opened or closed circles, do I? I just plow right on through that. And since I just plow right on through that -2, that means I equal it. There's no holes up here either, like this right here. I just plow right on through it, so this is going to be equal to as well. All right, now let's do one. I want to just remind you of one. Let's do, what if I had something that looked like this? Oh, you get those arrows on the end. That's actually green, but it definitely doesn't look green. Let me see if I switch to blue, if that'll help. Okay, so I see that this is continuous. I'm continually drawing. So that means my domain is going to be something less than x less than something, and my range, same thing, something less than y less than something. Because it's continuous. I'm drawing it. All right, well, how wide is this going to get? This arrow means it continues out this direction, forever and ever. So this is heading out to positive infinity. How far back the other way? It's going to keep going. So that's going to be negative infinity. Low to high, yes, you need to label it positive and negative infinity. You're never going to reach it. You're just going to keep getting wider and wider. The other option on this would be to say all real numbers. The domain is whatever it wants. But you know what else? How tall is it going to get? It's going to get forever tall and forever low. Negative and positive. So negative infinity less than x, or y less than positive. I'm sorry, I need like a nap. It's Sunday afternoon. Or I could say all real numbers. For me, whenever I'm doing ones like this, I honestly prefer to write out the words all real numbers. That way I don't risk making a mistake somewhere in here. Because if you were to tell me equals to negative infinity, I would count that off because you can't ever equal infinity. So when in doubt and you see those arrows, just think, oh, you know what? It's all real numbers. It's going to go on and on for forever. Okay, so that's kind of a short recap of domain and range. Now I've got this one. This is reasonable domain and range. This one, to me, these are easier because it's just common sense. So Martha sells tickets to a concert for $30. She has sold $90 already. So you might be thinking, oh, she sold 3 tickets. Yeah, you could think of that. What is a reasonable domain and range if she still has 10 tickets to sell? Okay, so good old Martha, she's selling these tickets. So if I were to graph it, or maybe I'll just write like this. I've got tickets that I'm selling, and I've got money that I'm making. Tickets will be what I sell, and the amount of money I make, well, that depends on how many tickets I sell. So X is going to be the domain, Y is going to be the range. All right. How many tickets can she sell? I'm giving you a sec to think about it. Okay, so here's what it is. I could sell, I'm going to use my Sharpies as my go-to. I could sell 1 ticket, right? Yep, I could sell 1 ticket. And then Tommy comes along and Tommy says, oh, I don't have enough money. Can I sell Tommy half a ticket? No, he can't sell much. He either buys a ticket or he doesn't. Tommy, sorry. He's going to buy a whole ticket. We could sell another ticket. We could sell another ticket. How many tickets do I have to sell? I have 10 tickets. So I might not sell any tickets. Oh, that would be awful. I could sell 1 whole ticket, 2 whole tickets, 3 whole tickets. Now watch this. You could list out all the way to 10 if you wanted. But I could also put dots like a sequence, comma, and then put 10 as my final one. If that confuses you, just put 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That works too. Now the range, this is how much money. You might be thinking, okay, well if she sells 1 ticket, it's $30. 2 tickets, it's $60. 3 tickets, it's $90. Yes, but there's a little catch that goes on with that. What is it? Hopefully you're saying, well, she already made some money. How much money did she make already? She already made $30. So I was trying to get my calculator cleared out. She already made not $30, $90. So if she sells no tickets, she's still at 90. But what happens if she sells 1 ticket? We're going to add 30 to that, right? So she would have $120. What if she sold another ticket? She'd be at $150. What if she sold another ticket? She'd be at $180. So the question is, what is the most that she can make? Well, let's see. If she sells 1, 2, 3, so that's 3 tickets. Let's do this. If she sells all 10 tickets at $30 each, right? She makes $300. But she already made how much? $90. So $390. So the most money she could bring in would be $390. And that's reasonable domain and range. Will it always be discrete like this? No, I could have like a Bryce Canyon. Let's talk about Bryce Canyon. I don't have it handy. But let's say, I'm going to draw this. Let's say that I'm hiking in Bryce Canyon. Let's say that this is 10,000 feet. We'll just keep it simple. And we'll say that this is 5,000 feet. And we'll say this is about 2,500 feet. Hiking in Bryce Canyon. This would be our time. Let's say that we hiked for, we'll say 4 hours. We'll say this is hours. So we'll say half of that would be like 2 hours. This would be like 1. Somewhere here would be like 3. Not the greatest, but you get the idea. So the question would be, what would the domain be? Well, the domain would be 0 less than or equal, X. Well, I'm just going to mark it out. X less than or equal to 4 hours. How tall is it? Well, I go all the way down here to 2,500. Less than or equal to Y less than or equal to, my highest range is 10,000. So this situation, reasonable domain and range, is time, 0 to 4 hours, height, which is 2,500 to 10,000 feet. All right. Function notation, that's something else we did. Function notation is where we're going to plug these values in order to get our answer. This first one, x squared right here, negative x squared, honestly, I would use my calculator for that. I would remember that f of x is a fancy way of saying y. And I would say, okay, well, let me put this in. Negative x squared plus 2x minus 1. And I need to know when x is negative 2, what is my output? So second table, I'm going to come over here and I'm going to go when x is negative 2. And I see negative 9. Right there. So one more time. Y equals, here it is. I just plugged it in because I know that f of x is a fancy way of saying y. I need to know if x equals negative 2. If x is negative 2, second table, what is the y? What is the output? And I go here and I find x is negative 2 and I see that it's negative 9. So f of negative 2 is negative 9 plus. Now, I'm going to do this one. What if I told you you couldn't use a calculator? Because there might be one on your test like that. This is x equals 3, right? And I'm using g of x. So I'm going to say g of 3 equals negative 3 times 3. I'm going to insert this 3 in for the x, plus 2, negative 9 plus 2, which would be negative 7. So g of 3 is negative 7. Negative 9 plus negative 7 is negative 16. And there it is. So there is one, it's very similar to this one right here, that I say, show me how you would solve that without a calculator. Right here's your answer. Just show me the steps. You could check it with your calculator. That way you know for sure you got it. Function notation, I think that was everything I wanted to show you on that. Let me just double check. Oh, create a table. Yeah, let me do that with you. So if I were to give you f of x equals 5x plus, we'll say 10, could you create a table and graph that for me? Yeah. Well, I would do this. If I'm doing this, I'm going to go here and I'm going to go y equals. I'm going to put in 5x plus 10. I'm going to go to second table. I'm just going to pick some numbers. I like to pick ones that are easy, so I almost always pick 0. 0, 10. I'll pick 115, 220, maybe one more, 325. There you go. I created a table using my calculator. You're going to have your calculator for the test. 0, 10 might be here, 115, 220, 325. The question is, do you connect them? Yes. If I ask you to graph this continuous function, then that means I'm saying it goes on for forever. If I tell you it's continuous, it does not have boundaries. And that's it. I'm going to give you a function, ask you to make a table and graph it. Super easy on that. This test is ridiculously easy. Okay, the last thing you have is sequences. I'm going to give you a sequence and I'm going to say write the rule. Well, remember the rule, and I will give it to you if you need it. I'll probably just put it on my board, is the first term plus the common difference times n minus 1. All right, so let's remind everybody, what is a sub 1? First term. D is the common difference. What is this going? Oh, this one's getting smaller. So this one's common difference is negative, and you can see 10 to 16 is easy to see, that's 6. It's going down by 6. The first term is negative 4. So I'm going to plug negative 4 in here and negative 6 in here. A sub n equals first term, which is negative 4. Common difference is negative 6 times n minus 1. We are going to leave it right there. That is my rule. Here's what I'm going to also do on this one, though. I'm going to change it up just a hair, and I'm going to say, because I've done this with you before, what if I give you a situation? Cody has 25 stuffed animals and plans to add 2 per month to his collection. Okay, think about this rule right here. Could you write the rule? Okay. So, I'm going to say that he starts with how many? Right here, a sub 1. He's starting with 25. What's his common difference? What's he adding every year? He's adding 2. That's your books. So, plus the common difference times n minus 1. Now, I wrote the rule based on how many he started with, how many he's adding. This is super easy when they just give it. The question is, could you write out the first 7 terms? You could. How many does he start with? 25. Okay, on the second month, how many is he going to have? Well, he's going to add 2 little stuffed animals. So the second month, he'll have 27. The next month, he'll have 29. Y'all should know I did this problem based off of me. I used to collect stuffed animals. 31. I had 150. And then my house burned down when I was in high school, and I lost all my little stuffed animals. I know, it was very sad. 33, 35. Okay, I said 7. 1, 2, 3, 4, 5, 6. One more. Could I write out the first 7 terms? You bet. But always remember, comma, dot, dot, dot. All right, sequences, that is about it. Maybe, yeah, I think on this test, I just want to ask you to write a rule. I think on this one, I use something like Yellowstone. I love the Yellowstone problem. And I think I use moose in Yellowstone. So I'm just going to double check. I'm going to look at my test real quick and make sure we're graphing. Oh, I know. There was one other thing I wanted to remind you of. I put it on the first page and I forgot to go over it. Right here, discrete and continuous. Discrete. Tell me something that is discrete. M&M's in a jar. That would be discrete. Cars in a parking lot. Peanuts in a jar. I'm drinking a Pepsi cherry. I know you're all probably like, oh, gross, Miss Dean drinking Pepsi. Yeah, I like Pepsi. The Pepsi in a can, what would that be? Would I measure that, or would I count all the little droplets of Pepsi in my can? No, I would measure it. So that would be continuous. The markers that I'm using, how many markers does Mrs. Dean have? That would be discrete. I'm counting the markers. If I were to take this and graph it, there it is. Is this discrete or continuous? A line on a graph would be continuous. If I had dots, points on a graph, that would be discrete. Okay, so be sure you know those differences. And the last thing I wanted to remind you of, I'll just go right here. We talked about it the other day, but we didn't talk a lot about it because it's so easy. All right. I give you a graph right here. I'm going to put endpoints on it. And I ask you, what are the zeros? Remember, heroes stand tall and zeros lay down. The zeros are nothing more than the x-intercepts. So let's circle them. X-intercept, x-intercept, x-intercept. So there's 3. Could you tell me the y-intercept? I could. Right there's the y-intercept. It doesn't have a fancy name other than it's the y-intercept. Sometimes we call it b. But these are called the zeros. So I'm going to give you a picture and ask you to do nothing more than circle the zeros. I'm going to keep it real straightforward and real simple. All right, y'all. I hope that helps you out as you're preparing for your test this next week. Thanks for watching. As always, have a great day.